Hi, I'm Joe Feeks, editor of Poultry Health Today, and with me is Dr. Daral Jackwood. He is a professor at The Ohio State University. Dr. Jackwood, thank you so much for joining us today.
You're welcome.
Now, most folks in the industry, some might know you as a professor. I would say the vast majority would say he's the infectious bursal disease specialist. How did that become your specialty? What's the attraction?
It's interesting that I started out my graduate career looking at a bacteria that was infecting poultry, and it was very clear to us early on that immune suppression was a problem with this disease and exacerbating the disease. And so I got interested in what causes immune suppression in poultry, and as my PhD dissertation, I did it on infectious bursal disease and the immune suppression and the related sequelae that occurs from that. And I just carried that over into my career. It didn't seem like there was a whole lot of people doing molecular biology in this particular virus. And so it was very interesting to me, not only the virus itself, but how it causes immune suppression and why we're having so much trouble controlling it.
And why are you having so much trouble controlling it? Are there different variants that come along all the time?
Yeah, so in the 1980s, it was discovered that there were genetic variants of this virus. And the variants were escaping the immunity that we were getting from the current vaccines. And so that was the definition of variant. We were using these vaccines, they had been known for probably 20, 30 years, and all of a sudden they weren't working. And it was because these antigenic variants came about, and the first one was found in Delaware on the Delmarva Peninsula. And those variants were a problem enough that they actually made some vaccines to them. The problem was then new variants arose. And so it was just this chasing of the new virus as it evolves with another vaccine, and it became very apparent that we weren't going to win that battle using conventional vaccines. About the same time, some very virulent viruses came on the scene right around the 1980s also. And they started out in Europe and spread through Asia and the Middle East and into Africa and eventually South America, Central America, and now even we have some isolates from the US on the West Coast. And that is another type of variant, but in that case, it's a pathogenic variant. So these terms get to be very confusing. So we have these, what were the classic viruses, they call them. They were the original ones that were isolated in Gamboro, Delaware in the 1960s. And then we have these antigenic variants that were isolated in Delaware in the 1980s. And we have these very virulent viruses, again, that became very apparent in Europe. And so those are the three major designations. Two antigenic ones, classic and variant, one pathogenic one and very virulent, but there's a whole range of viruses that are in those three groups, so it's not black and white. It's a much more gray than that.
And so obviously producers work closely with veterinarians, but what do they need to understand about all these different labels, all these different adjectives when planning their vaccine program?
Yeah, so with vaccine programs, the key thing is getting the antigenic strain of your vaccine to match with the antigenic strain of the field virus that's causing the disease problem. And so the terms that are used for antigenic differences, classic, variant, new variants, Leuchert strains, all those terms are referring to different antigenic types. And those are the ones you need to pay attention to, because those are the ones that are going to make or break your vaccine program, because you've got to match the vaccine to what you're seeing in the field. The very virulent ones, and then there's a classic virulent, and there's a subclinical virus, those are all pathogenic terms. And so those different pathogenic types can have similar or dissimilar antigenic types. So you got to just remember that you're either talking antigenicity or pathogenicity with these terms. And that might make it a little bit helpful for producers when they start thinking about bursal disease viruses and which one is this.
So again, how should a poultry operation go about planning their vaccination program if this virus is always evolving?
Sure. So the major thing that we need to do for vaccinating against this disease is protect the very young birds. That first 2 to 3 weeks of life is critical, because that's when the virus is infecting the B lymphocytes and causing the immune suppression. If we can protect them at that young age, then we can get them out to an age where the secondary lymphoid organs have been seeded now with these lymphoid cells, particularly the B cells, produce antibody. And those birds get a transient immune suppression during the disease, but they recover. And so that's what we're looking for, trying to get them older. And to do that, we use maternal immunity. So we're vaccinating breeder flocks, and we're relying on the antibody to be transferred from those breeder flocks through the egg into the young broilers. And when the antibody titers are high enough in those young broilers, and they're the right strain of antibody, in other words, the breeder birds were vaccinated with the strain of virus that those broilers are going to eventually see in the grow-out house, then we get really good protection out to 21 days, sometimes even 26, 27 days of age. That's what we're really looking for. Beyond that, we're going to get infected with bursal disease field virus. It's going to happen. The maternal antibodies are going to wane. And so getting a vaccine in the birds that will help protect them as the maternal antibodies come down is also important. In the past, we've used live attenuated vaccines, and timing of that was very difficult because you've got these maternal antibodies that are going to block the live virus. So you needed to wait until the maternal antibodies got low enough and then vaccinate with a live attenuated virus. And then what happens is you still had a window where the birds were susceptible before the active immunity started. The advent of the recombinant vaccines, the HVT, IBD, the recombinant herpes virus vaccines that are expressing the bursal disease virus VP2 gene, those are given in ovo usually, sometimes at day of age. And those herpes virus recombinant vaccines then can be given while the maternal antibodies are high, so you don't need to worry about that. And they will give a fairly nice cross protection in these birds as they get older. It's a longer story than that, unfortunately, because what is happening, particularly here in North America, is that the variant viruses, as they evolve and change, are breaking through the maternal immunity that we're trying to keep in these young broilers before the antibody from the vaccine, the Vaccitech or the Vector Immune or whatever HVT vaccine they're using, kicks in. So you still have bursa damage, you still have these viruses infecting these birds because the maternal immunity wasn't the right kind or wasn't high enough, the birds weren't vaccinated properly or what have you. And once those bursas get infected at 14 days of age or even 16 days of age, those birds are going to be immune suppressed, and doesn't matter what vaccine you use after that, it's just not going to create a strong enough immunity to protect that immune system.
Daral, how much of a problem is viral shedding with infectious bursal disease?
It's obviously a problem when you're talking about the field viruses. They get into these birds and that's how it's transferred. It's a fecal-oral route of infection. So eventually these birds are going to shed the virus in their feces. We did a study once where we looked at cloacal swabs and tried to identify virus in the cloacal swabs, and it was timed throughout the infection of the birds, and there was a very short window when they shed this virus. Apparently it's shed in large numbers, but it's just a very, very short time. So that sample as a diagnostic wasn't very good for us because the timing had to be impeccable in order to get a positive result. The HVT recombinant viruses, the herpes viruses that are expressing the IBD genes, are not a problem at all because these are herpes viruses. They stay in the bird for a fairly long period of time, stimulating the immune system during that time, and there's no infectious bursal disease virus there at all to worry about being shed.
Now, I've heard some people talk about maybe rotating vaccines for infectious bursal disease. Does that make any sense?
It does if you don't know what your field virus is. So if you are guessing at what is actually causing this bursa damage, you're not quite sure whether you've got a classic virus or some variant strain, then rotating vaccines is probably a good idea. Eventually you're going to hit on one where the performance of the flock is going to improve, and then you can stick with that one until it starts not to work again, and then you rotate to a different one. It's a much better way to, or a much more scientific way to do this if you do diagnostics first. So if you do the diagnostics, figure out what your field virus is, and then go looking for a vaccine that closely matches that. And we know enough about the virus now at this point that we can create or do the sequencing of the gene of that virus, identify the key amino acids that we know are contributing to antigenicity, and then look for those same amino acids in a vaccine.
Now, you mentioned the recombinant vaccines that are based on the herpes turkey virus. As I understand it, though, you can only use one vaccine that is built on that virus. So if you're going to use it for Newcastle or ILT, for example, you couldn't use it for IBD.
Correct.
And so if you're in that situation, what kind of approach would you take?
Yeah, I was actually talking to a producer this morning who was doing that very thing. In the fall, they switched off the bursal disease recombinant and went to a different one, either Newcastle's or one of the others. And so what they were seeing is an increase in immune suppression related disease as a result of doing that. And then in the spring, when they didn't have to worry about the other diseases, they then went back to the recombinant bursal disease virus one, and they saw an improvement in feed efficiency and growth rate, and they didn't have uneven flocks anymore. And so it does make a difference. There are alternatives. These immune complex vaccines are one of them. This is where you have a live attenuated virus complexed with an antibody that binds to it. And those can be given in ovo or day of age, just like the herpes virus recombinants. And those viruses, they are live, so that's a consideration, but they are simple to administer because, again, it can be done in ovo, and they do provide some protection to the bird as the maternal antibodies wane. So if you do have to come off a recombinant herpes virus vaccine because you've got other problems, that might be one solution to that problem, where you can continue to get some active immunity in the birds by using one of these immune complex vaccines. The other option is going to a live attenuated virus and trying to time the maternal immunity drop. And there are still some companies that do that, but that is a slippery slope, and that's a tough one to do. You really have to be vigilant with the antibody titers in those broilers and really time that live vaccine just right.
With the industry moving away from antibiotics, in some cases eliminating them altogether, or some producers are just cutting back on them, does that increase the importance of maintaining a healthy bursa and in turn optimum immunity?
Yes, of course, yeah, because with immune suppression, doesn't matter what's causing it, but bursal disease is probably the primary cause of the immune suppression we're seeing in the field right now. That immune suppression leads to secondary infections, opportunistic pathogens, and there's plenty of them in the respiratory system and the gut of poultry. Once they're immune suppressed, then these bacteria start growing and we get air sacculitis and all kinds of other problems, which in the past were handled with antibiotics. A lot of producers 10 years ago, when we could use antibiotics, would just say, well, we're going to do a maternal immunity, and when that wanes, we're not going to worry about it, because if they do get, some bacterial infection, Clostridium or E. coli or whatever, we'll just treat them with antibiotics. Well, we can't do that anymore, and so it becomes very, very important to stop the immune suppression so that the birds don't get infected with those other secondary agents.